Hello guys, this is Akash. Welcome back to this YouTube channel Nurture with Lecture. In this video, I am going to discuss the top 15 questions for the JEE 2023 April attempt. That is, the chapter is mathematical reasoning. In mathematical reasoning, the top 15 questions that came in the previous years, and also these previous year questions are very important, so you can get the maximum marks in the April attempt. So the top 15 questions in the first question is here. Which of the following statement is a tautology? Like this, there are the remaining 14 questions. But before that, if you are new to this channel, please subscribe to this channel to get the notifications, and also join the Telegram group. The link is given in the description. So to access the notes and also the practice problems, you have to join the Telegram group. So basically, I have uploaded the handwritten notes of mine and also the Google Form links in the Telegram group, so you can access there. And also, if you are new to this channel, watch the previous sessions where I discussed the Changemakers batch series. In the Changemakers batch series, every chapter of mathematics JEE has completed in the one shots. That is around 1 hour, 1.5 hour to 2 hours. So you can get the one shots in the playlist section of this YouTube channel. So watch those videos also. And also, this is the mathematical reasoning. This is the first chapter which is discussing under the top 15 question series, which I have started recently. The first chapter is mathematical reasoning, the second chapter statistics. Like that, the complete mathematics syllabus will be covered. The top 15 questions will be covered for every chapter. So now let's get into this video and discuss the first question of mathematical reasoning. Basically, the first question is, which of the following statements is a tautology? What is meant by tautology? Tautology means the complete statement is true. It is said to be tautology. So basically, we have to, there are 4 options, and we have to check for these 4 options which statement is completely tautology. We have to check like this. So basically, suppose I am taking this D. So basically, in mathematical reasoning, that is MR, to solve the mathematical reasoning questions, you can solve the questions by using 3 methods. The first method is truth table. The second method is sets method, and third method is applying properties. In the Changemakers batch, when I am discussing the mathematical reasoning, I explained each and every method in detail. So if you didn't watch those videos, watch those videos. It will be really helpful. I cannot discuss the complete method here, but I can say what the method says us. That is the truth table. For there are 2 statements here, P and Q. So the individual statements, the truth values are calculated. So basically, the truth values, after we calculated what are the truth values we got, based on this we can say whether it's tautology or fallacy or the remaining things, and which statement is equivalent to the which statement we can say. And the set method is, that is Venn diagram. So basically, this is a Venn diagram. By taking the suitable Venn diagrams, we can solve, that is statement P and Q. We can solve like this. And applying properties, there are nearly 10 to 12 properties like involuntary, De Morgan's, and involuntary, that is commutative, that is distributive. Like this, there are so many properties in mathematical reasoning. So by applying the properties also, we can solve the question. So basically, we have to select the method where the calculation is less. So this question can be solved by 3 methods, but we have to choose the right method to solve the question. So for this question, we have to calculate individually. So here, applying properties as well as the truth table and sets, 3 will give the answers, but the minimal will be given by the truth table and properties. Suppose if we take the example D, P or P and Q. When I see like this, I can apply the De Morgan law here. That is P or P and P or Q. What is P or P? P or P is P only, P and P or Q. After this, we can apply the truth table, that is PQ statements, TTFF and TFTF. And P or Q. What is P or Q? P or Q is true, 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 false. Why I am taking like this? P or Q is nothing but if any statement, if one of the statement is true, then the whole statement P or Q will be true. So here TT, it is T, it is T, F, T only, FT, that is T only, FF, it is false, because at least one statement should be T, that is true. P or Q is completed. Now P. These P and P or Q is AND. These two we have to do AND operation. So you will get T here, and false here, false here. So we are getting this as we are getting this as P, not tautology. The tautology means we have to get T, 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 T. 4 we have to get T only. So the option D is wrong here. Like that we have to eliminate each and every option. But if you have luck, you can get directly to the right option. Suppose if I take the random option as B option I am taking, that is P and Q, negation P and Q here. What is the property here? What is the property of P or Q? Suppose negation P or Q. So applying property here, we will get negation of P and Q or negation P and negation of negation P or Q here. This is a complete thing here. And when I apply negation here, negation of or negation Q or P or Q. So basically if you see like this is a thing here. But this thing can be solved by truth table also. If you take P, Q here, T, T, F, F, T, F, T, F. What is P and Q here? T, F, F, F. This is P and Q. And what is not P? Not P is F, F, T, T. And what is? This is not P. And not P, Q, we have to do implication. What is implication? If the first statement is false, no need to check the second statement, directly keep as true only. That is negation P, implication this. And this is also true, and this is also true, and this is also false here, because if the first statement is true, we have to evaluate second statement. If the second statement is also true, then it will be true. This is a case, but it is false here, so it is false. This is complete, this one, and this is P and Q. These two we have to do implication again. TT what? TT, that is T only. This is T only, this is T only, this is T only. So here we got tautology. Tautology. So this option is correct. Like this you have to do. After calculating this, we can solve here. Basically this is OR only. We can clumps here P or P or negation Q or Q. Like this we can do. Here there is OR operation. So for OR, that is if P is happening and or P is not happening. Suppose like this only. If we do OR to this, what we will get? TT, TT. That is T only. That is true. True or true. True or true, what is true only, na? So like this, applying properties or by truth table, you can get the answer. So this is the first question. To make you understand, I said two methods here, that is applying properties and truth table. You can do any of them, but in some questions two properties will be, that is properties as well as truth table will be applicable. So to solve the question in a minimal time, you have to do these things. And now the next question is, P and R biconditional. This is second question. This is biconditional statement is given is equivalent to negation P. They only given. When R is, they are asking what is R. 4 options: P, negation P, Q, negation Q. So basically they are asking that P and R biconditional, P and not Q is equivalent to negation P. But that means this statement is completely equivalent to this statement when R is equal to what? They are asking like that. So we have to find the value of R here. You can directly substitute the values and you can find. But after finding all these things, you have to get the equivalent statement as negation P. You can take R as P first, negation P, like that you can do. But it is not the correct approach to see the by applying the options, but what you can do, we can able to take the truth table here, that is P, it is Q, T, T, F, F, T, F, T, F, and first we will do this, the right part, that is P and not Q. What is not Q? Not Q is F, T, F, T. If you are confusing why I am taking like this, you can watch the mathematical reasoning session in the change makers batch, because it is very important to understand why I am taking the truth table for this question only. I explained clearly why I am taking. So to solve the right side question, I am taking like this, and these two we have to do and. Here it is false, true, false, and it is false. This is P and not Q, this statement. And now P and R. Suppose if I take the first option as P and P, what is P and P? What is P and P? P and P is taking this only, T, 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 F, F only. When I take and to this same thing, you will get the same, that is P. P biconditional, this statement only. What is this statement? Means we have to do these two. The first option I am checking. I am checking option here. Why I am checking option here? Because the right side part I already completed. The left side part I have to complete. This statement I have to get negation P. So when I will get negation P? Suppose if I take P here, that is the complete statement P. P biconditional, this statement is this one. F, T, F, F. When I do these two statements biconditional, when we will get biconditional, that is P, T, T, F, F, Q, T, F, T, F. What is a biconditional statement? This thing. What is a biconditional? That is P biconditional Q. We can represent P and Q and P Q implication Q P. That is, when it is same, you will get T, F, F, T. T, F, F, T. That means the biconditional. Why I am getting the biconditional? When what is the P implication Q? T, F, T, T, and Q implication P, that is T, T, F, T. When I do and this, false, false, true. So the biconditional equivalent is like this. So in order to biconditional, you have to do like this. So for two things, when it is same, you will get true, but here it is opposite, that is FF, and here true, and it is true, that is FFTT. What is this? This is negation P. So the first option only correct answer. So you can directly see here. So when we take R as P, we are getting the complete equivalent as negation P. So what we are done here, we first do the right side thing and we equate it to left side thing. We can do directly. Suppose if we take here B, that is negation P. Suppose if I am not taking the first option as the primary option, if I take negation P, what P implication P and negation P will become? It is false. And false bicondition we are doing. False bicondition means if F implication this thing, F suppose this thing is like this only, F implication this thing and this thing implication F. Like this. F implication this is true only, true, and this is F only. But it is dependent on this thing, so we cannot determine this thing as negation P. So the option is P only. It may not be equal to negation P, and it is equal to another thing, that is negation Q or negation P plus negation Q. We can say like this, but the primary is this equivalent statement is equivalent to the negation P, and when R is equal to P. This is a thing here. And now third question. The Boolean expression is equivalent to the given options A, B, C, D. Q implication P and Q, P implication Q, P implication P implication Q, P implication P or Q. So basically they are asking, this is a Boolean expression and this Boolean expression is equal to what? They are asking. So now we have to take negation of P or Q and this is OR. So basically this is a thing. So by applying properties we can do the question here. When we take this negation to inside, it will become negation P or negation Q or Q. So when we clump this thing, when we clump this thing, that is negation P, this is what this is, negation Q or negation, that is negation Q or Q. What is the statement Q? TF, TF and negation Q, FT, FT. And when we do or do these things, you will get T, 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 T. That is tautology. That is true. Negation P or T. You will get when negation P is done with T, the complete statement is true. That is, this is completed tautology. At which statement you are getting tautology, you have to check. Suppose if I take option, random option as C, and if I do the truth table, P, what is P? T, T, F, F. What is Q? T, F, T, F. And what is P implication Q? P implication Q is T, F, T, T. And what is P implication Q? It is T, T, that is false. T, T, that is T, F, T, T. So it is not tautology. So it is, the C option is wrong. If we take D option, that is P or Q. What is P or Q? T, 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 F. And what is P implication P or Q? You will get T, 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 T. So here you are getting tautology. So the Boolean expression of this is equivalent to this. So because this expression is getting tautology and this expression is also getting tautology. So option D is correct. This is third question. Next, fourth question. The statement P or Q, implication P and Q is equivalent to, first option Q implication P or Q, second option P implication P and R, third option fourth option. So the statement P and Q implication P and R is equal to what? So I am taking this statement. So basically the logic here is, when they are asking what is this statement is equal to this statement, means they are asking that which statement is equivalent to same this statement. So at this thing we can do only two methods, that is by applying properties as well as truth table. By using these two things you can do, but don't go to sets method. So it will be very difficult for you to get the answer. Definitely you will get the answer, but it will be time taking. So when I take P and Q implication P and R, so basically what is the formula for this? Negation of P and Q or P and R. Negation P or negation Q or P and R. This is a thing. And this is R here. You can write negation P or P and R or negation Q. I am transporting like this. So this is a thing here. So when I apply, I am applying De Morgan law here. Negation P or negation P or R. This is a thing. Complete or negation Q. what is a negation P or P that is true, and what is a true that is and or. True and statement, any statement, what you will get? You will get the same statement. So negation P or R or negation Q. Now what you will get? Suppose this is a final thing, final answer, that is negation P or negation Q or R. I can transpose like this because the same operation. When I observe these things and when I take negation as common, I will get P and R or R. And when I observe these things, we can write this statement as, suppose there is a statement, negation S or suppose T. I can write this statement as S implication T simply. So same like this, I can write this thing as P implication Q implication R, which is option D. So like this you have to solve. So by applying properties it is simple, and here the truth table is also not preferred because the answer we got simply here by just applying properties. And next question is fifth question. The statement P implication Q or P implication R is not equivalent to. Option A, option B, option C, option D. So they are asking that the statement P implication Q or P implication R is not equivalent to which statement. So I am taking the direct statement, that is P implication Q or P implication R. So I am applying the properties. P, what is P implication Q? That is negation P or Q. And what is P implication R? Negation P or R. Here same operation. So I can interchange these things. So here I can do negation P or negation P, like this I can do, or Q, like this I can do. What is negation P or negation P? It is negation P only. So the final is negation P or Q or R. They are asking which the statement is not equivalent to, they are asking. So when I take the first option, P and negation R, implication Q, what is this? Like this only. So this is same. This thing is same. So this is the answer. But this is not the correct answer. These two are matching, but we have to find which is not equivalent. So I am taking the C option, P implication Q or R. That is negation P or Q or R. This is also same. So these two are correct, but not the correct options. And when I take D option, that is P or negation Q or R, negation P or Q or like this. So this is also equivalent. So what is the answer? That is B option. 3 options I have eliminated because when I open the that is when I apply the properties to A, C, D options, I get the same result. That is, I get the same result when I do the statement. That is, when I apply the properties in the question, I am getting the same answers. So what will be the remaining answer? That is B is the not equivalent statement to this. So this is the correct answer. And now, sixth question. Sixth question, let P and Q be two statements. Then negation of P and P implication negation Q is equivalent to option A, P or P and negation Q, option B as P or negation P and Q, option C as negation P or Q, option D as P or P and Q. So same, in this chapter there is no chance of twisting the question, because in this chapter there will say there is a statement, what is the equivalent statement to this, and they will ask, there is a statement, it is a tautology, which is a statement from the options is also a tautology, fallacy. These things will be repeating, but you have to learn the concept here. When we giving two statements, that is P and Q, we have to find different operations, P or Q, P and Q, P implication Q, P biconditional, contrapositive, converse. These all things you have to keep in your mind, how to do this, how to apply properties, how to apply sets, Venn diagram method, and how to do with the truth table. Why you are taking P and Q as TTFF, TFTT, TF. You have to remember all these things, because in this chapter there is no chance of asking the different type of question. All the questions which I observed from the previous years are the same thing, just the concept is here. You have to learn this concept. Negation of, they are saying that is equivalent to, which statement it is equivalent. When I take this negation to inside, I will get this thing, and this statement is what? When I take from this thing negation back, negation of P and Q. What is negation of negation? It is negation only. Means negation will cancel. That is P and Q. This thing. And when I do the De Morgan law, I will get negation P or P and negation P or Q. And what is this thing? This is true. True intersection negation P, Q. True intersection any statement is that statement only, negation P or Q. Where the option is negation P or Q, that is C option. So like this you have to apply the properties. By applying properties it is very easy. And this question is from JEE Mains 2023, that is January attempt. You can see how easy the questions are coming in the mathematical reasoning. So by learning the concept in just 1 hour, you can easily get 4 marks from this chapter. That much easy this chapter is. Next, 7th question. The statement P and negation Q, P and negation Q, P implication negation Q is A equivalent to negation P or negation Q, a tautology, equivalent to P or Q, a contradiction. So basically this is a question. You have to see whether the statement is equivalent to option A, option B, option C, option D. Now first, P and negation Q. Implication, P implication negation Q. I am just applying the properties. P and negation Q or P, like this I am applying, because why I am applying like this, that is I know P implication Q can be written as negation P or Q. So by using this property I interchanged this question. So now it is negation P or Q, or, and now here negation P or negation Q. This is or I can interchange these things, that is negation P or negation P I can interchange, and next or Q or negation Q I can interchange like this. What is negation P or negation P? It is negation P. What is Q or not Q? That is true. So this is equal to negation P. It is equal to negation P. So where I am getting negation P? One second. Here it is negation P or negation P. It is negation P only. Like that. One second. It is true only here. Negation of like this correct only, or I have opened like this, negation P or negation Q, negation P and Q, or negation P or not Q. Okay, so I interchange like this, Q or not Q. Observe here. This is a final thing. Now negation P or true. Any statement we are doing true operation, that is or operation with true. What you will get? That is true only na. That is tautology. There is option here B. That's it. You have to check. Final. You are done the answer from to the final. But here you are thinking what to do next, whether it is negation P or T, or what it is negation P or tautology or fallacy. You are thinking, means I am thinking, you can also think, but up to doing the last thing you have to do one step more. After doing one step more you can get the answer. So don't stop at the before step only, do until the end and find the answer. Now 8th question. Eighth question is the statement B implication negation A or P, that is B, is not equivalent to A option, see, always the statement is not equal to, is equivalent to, like that only the questions are repeating. And now the statement B implication not A or B is not equivalent to, they are saying that it is not equivalent to which statement? So basically the not will take your 4 marks. What we will do? The statement this is equivalent to, and you check one option and it will be correct, and you keep that option only. But they ask not equivalent to, so you have to observe very carefully. B implication, negation and negation A or B. Negation B or negation A or B. What is this? Negation B or B or negation A. And this is negation B. Negation B or B. What we will get? You will get, if you have doubt, check once. TF, TF, negation B, FT, FT, T, 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 T. That is true. That is you are getting true. And true or negation A. And anything that is true only, na? That is, you have to get finally the answer as tautology. Which statement you are getting tautology? Observe one time. Suppose if I take option A, that is B implication A implication B, by applying properties negation B or negation A or B, and what you will get? Negation A or negation B or B, and here it is true. And you are that is true, that is tautology, means this option is correct. Means it is not the correct option, but it is equivalent statement. Now I am checking option B, A implication A biconditional B. So A negation A or what is this? A implication B and B implication A. Negation A or B intersect, that is and negation B and A. So here applying properties may be a tedious task. So I am directly taking truth table. TTFF, TFTT. So A biconditional B, that is here true, A biconditional B. I already said when the two statements is same, you will get true. If they are opposite, you will get false. And A biconditional to this. T here, false here, T here, T here. That is TFTT. So here you are not getting tautology. So this option is correct here. Means it is not equivalent statement. So these two statements are also correct. But these are equivalent statements. So these three options are wrong. Option B is correct. That is, which is not equivalent statement. Next, 9th question. Ninth statement, it is in ninth question contains two statements. That is statement 1, P implication Q or P and not Q is a tautology. And statement 2 is negation P implication negation Q and negation P or Q. Is a contradiction. Then you already know when there are two statements, what are the options will be? A, B, C, D. Statement 1 is correct, statement 2 is correct, but here statement 1 is correct, statement 2 is wrong, statement 2 is correct, statement 1 is wrong, both statements are correct, both statements are wrong. Like this there will be options. Now first I am checking first option, that is P implication Q or P and not Q. So this is P or Q or P and not Q. So I can interchange this. I am interchanging these two things. I will get, and here negation P or P and negation P or negation Q. I am interchanging like this, and this thing is or, doing or operation. You will get this is true, and anything and negation P or negation Q or Q. Here true, anything we are doing true, and doing AND operation with any statement, what you will get? You will get the same statement, that is negation P or negation Q or Q. And what is this thing? And again this is true, that is negation P or true, and anything it is true, we are doing OR operation, we will get true only. So the first statement is correct, that is the first statement is tautology. And what about the second statement? Negation P or negation Q and negation P or Q. You have to solve this thing, that is P or negation Q and negation P or Q. These thing, two things you have to solve. So suppose I can take here truth table TTFF, TFTT, TFTF. So P or not Q. What is not Q here? Not Q and not P. FT, TFF, TT. So first I have to do P or not Q. P or not Q. That is true here, false here, true here. And negation P or Q. Negation P or Q. What I will get? I will get T, false, T, T. And these two things I have to do AND. What I will get? T here, false here, T here. I am getting this thing. That is, this complete statement is TF, TT. This statement is equivalent to biconditional statement, that is P biconditional to Q, and not a contradiction. So the answer 1 is correct, that is statement 1 is correct and statement 2 is wrong. And the next question, that is 10th question. The negation of Q or not Q and P is equivalent to option A, option B, option C, option D. So basically this is a next type question, that is they are giving one statement and they are asking the negation of this statement. So negation of Q or negation Q or and P. What you will get? Negation Q, when I will take this negation to inside, negation P and a negation of negation Q and P. So negation Q and Q or negation P, like this you will get. And what is this? Negation Q? 1 second. The negation of this statement, sorry, here when negation enters, it is negation, 1 minute. After this, that is negation Q and Q or negation P here. So this is, it is false or not P, you will get not P. What is not P truth table? That is FFTT. So which statement it is getting? We have to check. Negation P or negation Q, I am checking this. I will get, what is negation P? This is P, this is Q. T, T, F, F and T, F, T, F. What is negation P? F, F, T, T. What is negation Q? F, T, F, T. And these two things are F, F, T, that is F, T. So it is not equivalent to this, so it is wrong. And second option, P and not Q, P and not Q, and it is false, true, false, false. And it is also wrong. Next, third option, negation P or negation Q. Negation P or negation Q. It is F, T, T, T. So it is also wrong. Final option, that is negation P or Q. Negation P or Q. T, F, T, T. One second. P and no, not Q. It is false. It is true. One second. The statement is not of P or Q. What is P or Q? P or Q is, one second. There can be an error here, or and you have to check a question very carefully. Negation of Q or not Q and P. Negation Q and not of Q and P. Negation Q and Q or not P. This is false, false or not P, that is not P only, not P as FFTT. And negation of P or Q. The first statement is negation P and negation Q. And you will get, when we take negation as common, you will get P or Q. Why it is not equivalent? Leave it, it has error. Next, 11th question. One second. In the 10th question, we can solve by truth table. 1 second, I will check with the truth table. If I take the option as first option, and let's check whether these two are correct or not. Suppose if I take P and Q, T, T, F, F, and T, here T, F, T, F. What is P? Negation P here is F, F, T, T, and the negation Q here is F, T, F, T. What is negation Q and P? It will get false, true, false, 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 true, false, false. This one. And it, to this you have to do OR with T, that is Q. You will get T, 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 F. Yes, so the complete thing is like this. When we do this thing, it is negation of P or Q now. What is P or Q? What is P or Q? That is T, 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 F. What is negation of this thing? F, 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 T. So this is a contradiction here. So you can do like this. It is a contradiction. So this is the correct option. Option A is correct. Yes. And now 11th question. The number of values of R for which So this is the question. The number of values of R is belonging to PQ, negation P, negation Q. Basically, you have to replace R with these things, and how many of these things can do this correctly. So this is the complete statement will get we can get correctly. So now I am taking the truth table. You can get do with the truth table, or you can simply solve by using properties also. But here I am taking the truth table. First I will take the complete statement P and Q. I am taking truth table, but first I will take P, whether P is correct or not. In R place I am substituting P. I am checking. When I do this thing, before applying the truth table, first solve this thing. What is P and P? It is P only, na? It is P only. We have to get the tautology. So, and next we have to solve. Here it is negation P. It is negation P or Q, because it is negation of P or Q. It is negation of P or Q, or P or Q and P implication Q. First I solve this thing, and when I apply this thing also, you will get negation P or negation Q and or negation of P or Q and P or Q. Negation of P like this, negation P or negation Q and negation P or Q. So here so this is complete statement we can take here. This is a complete statement, and we can swap these things. We can swap this, that is negation P or negation Q, or negation P or Q, or this thing negation P and negation Q. We can write like this, and we can clump this, that is negation P or negation P, or negation Q or Q. What is negation P or negation P? That is negation P only. What is negation Q or Q? That is true. And when you are doing true to any statement, that is completely true. And when you are doing anything statement true, it is same. That is true only. So this is tautology. So for taking P, we are getting as correct only. That is tautology. So the P is correct here. Suppose if we take in the place P, if we take Q, what changes we will get? That is P and Q, Q or Q, and P and Q, implication Q. Here also same procedure. What is Q or Q? What is Q or Q? It is Q only. Implication Q. Now negation P or negation Q, and for this I am doing another step, that is implication. I will get negation Q or negation P and negation Q or Q. So here I can clump these things. So basically what is this? This thing is negation Q only, and this thing with this thing, I will get negation P only. So these all things have went already. And what is this thing? This thing is negation Q or Q. What you will get? You will get true here. You can check here. T, F, T, F, F, T, F, T. When you do OR, T, 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 that is tautology only. That is true. So basically, this is any statement you are doing OR operation, you will get true only. So the Q option is also correct. Now we have to check negation P and negation Q, whether these options are correct or not. So it can be a lengthy process, but this is a right approach. P and Q implication. Suppose if I take negation P or Q and P and negation P implication Q. What is negation P and P? That is, it is false. It is completely false. And what is when we do intersection, that is and with any statement, that is false. False, we are doing and operation to any statement. What you will get? You will get false only. You will get false. And false implication Q, you will get always true. And P implication Q to true. That is, what is P implication Q? You will write like this: negation P or negation Q or true. And we are doing is this correct? This is false only here. Yes, it is false. We are doing and with anything, we are getting false only. False implication Q, that is negation false or Q, negation of false or Q, that is true or Q. We are for true, you are getting true only, this thing or true. So here it is getting wrong. Let's check negation Q here. What you will get when we apply negation Q? This is true here. And when we do true intersection this thing, the complete statement is this only. This is negation Q here. And when you solve this, negation P or negation Q, or P implication negation Q or Q, negation P or negation Q, negation P, this thing, like this. So what is this thing? This is Q only. And what is this thing? It is negation P or either negation P, negation Q, negation Q or Q. What you will get? One second. Up to now it is correct only. Negation P or negation Q or negation P or Q or Q. Here it is Q only. And negation P or negation P, you will get negation P only. And negation Q, that is true only. Basically, from the first two options, that is P and Q, are getting correct, that is tautology. So the option is B here, that is tautology. So the number, what are the number values of R? That is, there are two values of R. So that's it here. So basically you have to check each and everything, or you can do directly with the truth table, or you can directly apply the properties. And next this is another pattern, that is, I have fever, and basically I am not having any fever. Here in this question it has given medicine or I will take rest. Now they are asking the statement, if I have fever, then I will take medicine and I will take rest is equivalent to. They are asking, this is a statement. If I have fever, then I will take medicine and I will take rest. Up to now, up to this. These are the same statements. Suppose if you substitute this thing, that is if I have fever, that is P statement. If P then Q, that is I will take medicines. I will take medicines is there here, but here I will not take medicines. So it is contradiction to this, that is negation Q, and that is and here I will take rest. I will take rest, that is R. So how we can write this thing to the equivalent statement? Basically, if P then something. It is implication. That is P implication not Q. And in between it is R. So basically this is the answer. This is a equivalent statement. So by seeing the statement, whether you have if then and anything, if and if only, that is biconditional, you have to observe. So the given statement is like this. So we can write this statement as this. That is P implication not Q and R. So this is the answer. And next, and again, now 13th question, statement 1, P or Q, implication R, P implication R, statement 2, P or Q, R, so basically these are the two statements given. You have to see the options for this is statement S1 is tautology, neither S1 nor S2 is a tautology, only S2 is tautology, both S1 S2 are tautology. Means you have to check whether it is tautology or not. Suppose I am taking statement 1, that is P or Q, like this, biconditional P or Q. So when I use properties to this, that is negation P or Q or R, biconditional to P implication R. That is P implication R can be written as P or R. And what is here? Negation P and negation Q or R, biconditional to negation P or R. Suppose this is a statement and this is a statement. What is a biconditional to this? That is, suppose this statement is T and this statement is yes. We can write this statement as T implication S and S implication T. Like that I am going to write this statement. Negation P or negation Q or R, implication negation P or R that is and negation P or R implication negation P, like this. So when I again apply the property of implication, I will get negation of negation, this thing, and when I apply this thing again, P here or Q here and here P and not R, or negation P and negation Q or R, and you have to solve this thing. So basically we can clumsy here. What are the things present? We can clumsy here. So basically here this is a single statement here. This is a single statement. here these two things can be merged, or and not or and not what it is? False. It is false here. And this is a single statement, and we can clump negation or and we can substitute negation or but at the last false we are doing and operations with any statements. What we will get? That is false and anything we are doing, we will get false only na. So it is not tautology. Similarly, in the second statement, basically this is a reverse of the statement, that is statement 1, statement 2. Basically these are interchange statements. So when we solve this statement 2, you will get statement 1 only directly, because here you will do directly negation P and a Q or R. So when you solve this thing, it is same this thing only. So neither, that is option 3 is correct. That is neither S1, S2 or tautologies. So option C is correct. And now and this type of questions are also repeating very much. That is, this is a 14th question. Suppose there is a triangle and suppose these things, these two symbols belongs to or that is and or, such that P implication Q box, that is triangle, and P symbol Q is a tautology. Then there are combinations now. Option A, option B, option C, option D. That is, you have to match the symbols for which this statement is tautology. So I am taking the statement, that is P implication Q symbol P symbol Q, and now I can take the guesses. That is P implication Q. Suppose if I take or, and here if I take Q, suppose if I take like this, what I will get? I will check whether it is tautology or not. What I taken? This is N, that is, and this is or. This combination I have taken, and now I am checking negation P or R. And suppose if we take here P, Q, T, T, F, F, T, F, T, F. What is negation P? F, F, T, T. What is all of these things? T, F, T, T. And what is the AND of P or Q? What is P or Q? T, 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 F. And what is the AND of these two things? That is T, F, F, F. It is not a tautology. So this combination is wrong. So now I am choosing the next combination. Same thing, but now I am changing the combination as this only, but this as this thing. What is the combination present in this? Means this combination is wrong. A option is wrong. Now I am checking this option. Now I am checking this option. That is both and only. If I do like this, so here it is also and. So when it is and, you will get directly here we have to do P and same thing, but see here, negation P, F, F, T, T, negation P or Q, here, T, F, T, T, but we have to do AND now. That is P and Q. This is this thing. These two things we have to do AND. So here also you are not getting tautology. So this combination is also wrong. And now I am taking the third combination. That is this thing as this and this thing as this. So what it will change? It will change P implication Q or P and Q. Negation P or Q or P, like this. Now PQ, TTFF, P and Q, TFFF, this thing, negation P, F, T, T. These two things are T, F, T, T. Here also you are not getting. So this combination also wrong. This combination also wrong. So the option is C. So this is a way to do this type of questions. You have to check each and every option, each and every combination, not each and every option. At any combination you can get the answer. And the final question now, 15th. The 15th question is P implication Q and P is equivalent to which statement? So basically we have to deduce this and you have to inform. So basically now I have to solve same properties, that is P implication Q and P. So first I will solve this thing. I will get negation P or Q and P, and now I will solve this thing. I will get negation P or Q P, like this I will get. So basically negation P or P and P. What is this? Negation P. So the final thing is what is the equivalent statement here? That is P implication Q and P. This is the answer. Basically this thing can be deduced like this, because negation P or Q and P. So this is the same two statements. So basically this P implication Q and P is same as P implication Q and P. This is the answer. So basically we have completed the 15 questions in the top 15 question series of JEE 2023 mathematical reasoning chapter. So that's it for the video. If you like this video, subscribe to this channel and also join the Telegram group, and also access the handwritten notes as well as the problems to practice. So that's it for the video. Thank you.